And good morning, good afternoon, good evening, wherever you're at, ladies and gents. This is Mr. Callen with Lesson 2-5, Chapter 2, Section 5, Computing Decimal Quotients. That would be a division term. If you have not completed this assignment, fast forward through this page. Meanwhile, everybody else, I'll reveal the answers, and you may go ahead and check your work from assignment number 9. Pause, and when you're ready to come back, come on back. And so let's go ahead and move on to today's section, ladies and gents, where we will be doing I will divide decimals with a whole number divisor. And so, look, we've already been multiplying decimals, so now it's time to divide them. Now, why would we have to learn this skill? Well, if you look up above in the purple, eventually we're going to get equations with decimals, and there will be division as a part of them. Sooner or later, you'll also get to dividing monomials, things like 14a to the 6th divided by 7a to the 2nd. So the division skill in general will be important. I should also point out that eventually you will get to dividing decimals by divisors that are also decimals. We'll probably get to that tomorrow. Why don't you go ahead and pause for a moment, title your paper, please, name, date, period. You're either looking at this on the 1st of September or the 2nd of September. Page 39, 11 through 21 odds, and then write all those problems down, 24, 27, 30, 31, 34 to 38 all, and 44 to 48 all. Assignment number 10, computing decimal quotients. Don't forget from now on, and Mr. Callen's going to be awful stickler on this, you're writing down all the directions. Just one time above a whole section, write down the directions, and then write down the problem, the original problem, your work, and your answer. Now, exceptions to that, we do not write out the entire word problem. And then if I ask you to do some mental math, I'll try to remind you, but you do not show work when you're asked to do mental math. Okay, hit the pause button. Go ahead and title your paper everything above that line, and then we will continue. So here's where we're heading, ladies and gents. We're going to try to divide 2 and 25 thousandths into 27 parts. Now, anytime you're doing any kind of computation, the first step should always be come up with a good estimate. Use your number sense. How can I split $2 among 27 people? Well, everybody's getting pennies. We're talking, I don't know, eight pennies maybe, something like that, if I split $2 into 25s or quarters. So just recall that we're definitely having no holes here and then some small parts. I'm going to go ahead and I'm going to write out the division. 2 and 25 hundredths divided into 27 parts. I'm going to go ahead and move this little to the side. Now, naturally, I'm going to bring my decimal point up and notice that, well, 2 wholes cannot be split into 27 parts. Some of you will skip this next step, but others of us like to bring 2 minus 0 2's down, and then we bring down the next place value of 20. Oh, guess what? 20 also cannot be split into 27s. So once again, I'm going to bring that 0 down and then bring down a 2. All right, we know that 202 can be split into groups of 27. The question is how many? Now, I'm going to be honest, kind of tough for me. I'm just going to whirl it here and say 6, and let's find out what happens. Now, 6 times 7 is 42. That's a good sign. Carry the 4. 6 times 2 is 12, plus 4 is 16. And if I go ahead and subtract, I get, whoa, wait a second. That does not work. Just a reminder with division, ladies and gents, that if your remainder is larger than your divisor, in other words, we could have taken out another whole 27 group, then that 6 will not work. We have to begin again. I will erase the 6, and I will erase the 162. Now, I said one more 27 could have come out, so instead of 6, let's go ahead and try 7 and see if this works. If you have to go to the side, you're always welcome to go to the side to do your multiplication. 7 times 7 is 49, carrying the 4. 7 times 2 plus 4 would be 18. So we go ahead and take 189. And when we subtract these, I'm going to have to regroup one of the hundreds. And then I'm going to have to regroup the tens to make 12. When I look at this, I see, hey, that's good. No more groups of 27 could have pulled out of there. So let's go ahead and pull our place value down. And how many 27s can go into 135? Well, 7 was too big, so I'm going to go down a little bit. 6, I think, was going to be too big as well. Let's try 5 and see what happens. If you need to go off to the side, you're welcome to do that. 7 times 5 is 35. Carrying your 3. 5 times 2 plus 3. Hey, look at there. With no remainder, we can stop. There is no need to keep writing zeros. There are no more significant digits. Our final quotient is about 7.5 pennies, which my estimate was 8 pennies, 800. So that's not a bad estimate at all. The key is reminding you that if the remainder is ever larger than the divisor, you have to go back and try again. Let's try 10 and 32 hundredths divided by 43. 10 and 32 hundredths split into 43 parts. First, come up with my estimate. Well, 10 cannot be split into 40. Well, it can, but it's tiny little pieces. So I don't know. Maybe the answer here is about a half, something like that. Now, I usually put a little tiny x, but you don't have to. Point 43 cannot go into 10. But if we bring the next place value down, 43 can go into 103 2 times. And if we were to regroup here, borrow from the 10, sorry, it's getting a little ugly. 13 take away 6, 9 take away 8, and no more 43s can go in. So we're happy about that. Bring down our next place value, 43 into 172. Well, sometimes, folks, I like to just kind of cover up a place value here. If I do it on both and say to myself, how many 40s go into 170? It's about 4. So let's find out. It's a good estimation technique. Sometimes we're a little too low, sometimes we're a little too high. In this case, 4 times 3 is 12 with 1 to carry, and 4 times 4 plus 1 just so happens to be perfect. So the quotient, I guessed a half. That's pretty close to 24 hundredths. Not a bad estimate at all. Onward we go. I think I meant to change that to a 42, but let's find out. 7 and 42 hundredths split into 14 parts. Once again, my estimate here, because I know 7 cannot be split into 14, so we're talking parts of a dollar, maybe a half again. We'll find out. So if you wish, you may bring that 0 down. It's totally up to you. Some of you go straight to 74 and say, all right, how many 14s will go into 74? I'm going to guess 5, because 5 tens is 50, 5 fours is 20, so that's 70. That's a pretty good guess. Again, check your remainder, because no more groups of 14 could have been pulled out of that. We know we're in good shape. Let's bring the next place value down. And in this case, look at that. It ends up being very close to my estimate of a half. Anytime you wish to check yourself, you can simply reverse the expression and you can multiply 14 times the part you just found. And it should come out to the original dividend. That's not the right word. Let's keep going on, please. Example 4, because we are about to get busy. 74 and 2 tenths split into 60 parts. Aha, all right, finally. So I'm guessing, well, at least 160 can come out of this, maybe 1.5, probably a little smaller, maybe 1.25, something like that. So my estimate, about 1.25, let's find out. So no 60s can come out of 7, but 60s could come out of 74. In fact, one of them could. With 14 left over, that is good. No more 60s can be pulled out of that remainder. So let's bring our 2 down. Now in this case, don't forget, you can always cover up a place value of each. How many 60s go into 140? And it's about 2. Maybe too big, maybe too small. Let's find out. So 2 60s is 120. And when we pull that out, we end up with 22. Hey, there we go again. So that works.
Good morning, teachers. This is just an announcement to let you know that if this internet/power outage thing is utilizing it, folks are working to get that up. This is last example.
That would be the internet being out. Sorry for that interruption. Let's carry on, shall we? So once again, if it helps, we're going to bring an extra 0 down. You can add, look, you can add as many zeros as you want. That doesn't really change the problem, but it does give us more place values. So how many 60s go into 220? I'm going to guess about 3. 3 60s being 180 with 40 left over. Hey, that was a good guess. So let's keep on going. How many 60s go into 400? Or again, how many 6s go into 40? I'm going to go ahead and guess that that's about 6. So 6 60s is 360 with 40 left over. Okay, let's keep on rolling, please. How many 60s come out of 400? That would be another 6 with 360 with 40 left over. And some of you already see where this is going, where we have a number of 6s. And when I say a number, I mean infinite. Wake up, Mr. Callan. Don't forget your decimal place. My apologies, I didn't show that. So, how do we write this answer? Well, there's clearly one whole. There's clearly 2/10, 300ths, and then the digits go on forever. Now notice only the 6 repeats. So we'll put a repeat bar only over the 6. If, on the other hand, both the 3 and the 6 repeated, if you have multiple digits, then you should put the repeat bar over both. But in this case, only the 6 repeats. So let's make that disappear for our final quotient, which was awfully close to 1 whole and 1/4. Again, don't forget to put your decimal point up. You should have put that up before you start. Sorry about me not doing that and the interruption in the middle. We only have a few things left, and that is some algebra. So let's get into the product of A and D plus an F, or we're going to go ahead and find the sum of F and D and B, or we'll go ahead and multiply A and B together. There's no parentheses there. I don't know why I did that. And subtract F. Now, in this case, anywhere I see an A, I'm going to put a 4. So here's a 4, here's a 4. Anywhere I see a B, I'm going to go ahead and put a 3. So here's a 3 for B, and here's a 3 for B. Anywhere I see a C, there is no C, Mr. Callan. Anywhere I see a D, I'm going to put 9 tenths. So there's a 9 tenths, there's a 9 tenths. And last but not least, anywhere where you see an F, we're going to put 2 4/10. And again, if you don't see any operator in between two variables, it does mean multiply. So from here on out, we're just going to go ahead with our order of operations in part A. 4 times 9 is 36 wholes, but 4 times 9/10, there should be 1 place value there. Now when we go ahead and add 3 wholes and 2 wholes, that's 5 wholes. 6/10 and 4/10 is 1 extra whole for a total of exactly 6. Now over here, our order of operations tells us we must divide first before we do the sum. So 9/10, if we had 9 split into 3 parts, it'd be 3 wholes, right? But 9/10 split into 3 parts would be 3/10. If you need to go off to the side, you're welcome to do that. Remember to bring your decimal point straight up, and it's a little easier to see than where that came from. All right, let's wrap it up. If we have 2 wholes and 4/10 and we add 3/10, it'd be just like adding 3 dimes, 2 7/10 as the finish. For part C, again, order of operations tells us to find the product first. Now think about doing this mentally if you can. 12 take away 2 is 10, but then we have to keep going down 4 tenths, which means we only have 9 wholes and 6 tenths. If you need to see that, you can write 12 and no tenths, take away a 1 whole, make it into 10 tenths, and now you see where the 6 comes from. Take away a 10 and make it into 10 ones with the 1 1, 11 ones, and then you can see that work. So that's what I have, ladies and gents. Once again, you're now beginning your assignment number 10. Please don't forget, you should be writing all directions, and then write the problem, work, and answer. Circle your answer if you could, please. And reminder that when it's a word problem, you do not need to write the entire word problem. You don't need to write 2 sentences, 3 sentences. Just go straight to the work and the answer. A reminder that if you're ever asked to do mental math, skip the work. You're going to write the problem and the answer. All right, let's hope this video goes through with our internet problems. Thanks, folks. See ya. Let's grow.